Hello, this is JVI with the James River Homebrewers. I'm going to talk to you a little bit today about the water testing that we're doing. First of all, the club decided a little while ago it would be kind of a neat idea to offer water testing to our members. And we went and we bought these kits. So these are the actual kits that we bought to do it. Essentially, we went with Hawk as the company. And these kits test a variety of different things that are relative to the brewing. And we bought them independently as the 4 different kits. Since then, they've come out with some actual kits that are actually specific to brewing and have some of this combined. But this was actually a pretty good way to go with it. And we were able to kind of pick and choose the right test for our needs. And this total, all 4 of these together, cost the club about $300 to invest in. So it's a pretty good investment for the club. And we can give that return. Essentially, we're going to test, 5 parameters today. We test hardness, and we actually do 2 different hardness measurements, a total hardness and a calcium hardness. We test alkalinity, and we're going to test for chloride, and we're going to test for sulfate. When you get all that, it gets you pretty much everything you need to know. From the calcium hardness and the total hardness, you can derive the magnesium from that, and we do that when we present the results. We'll calculate the magnesium as a separate value from the calcium. With the alkalinity, because we know the calcium hardness and the magnesium, we can actually calculate the residual alkalinity, and we also report that too on our reports. Calcium and sulfate, really the only thing we're missing here in terms of important ions for brewing is sodium. When we looked into that, and it was going to be about $1,000 to get a test that you could do any kind of sodium with, and it wasn't even a real good test at that point. So we decided that really, for that one parameter, people could get their water tested externally. You could somewhat derive it. If you know all of your anions and cations, you could assume that you have a neutral balance and it all would add up, but there's so much margin of error, as you'll see in these tests, that you're probably not going to get much of a reliable result doing that. Alright, so today I've got 6 samples, and people give them to me in some interesting containers. Important thing, of course, is to keep track of them, and so before I do anything, I always make sure I label the sample well. In this case, this is sample 1. It'll get a different number when I put it into the computer because we've really tested more than 0 samples so far. But for now, sample 1, and it also matches my very fancy sheet here that I use to keep track of my results as I go. So these are my sample numbers going down and the parameters that I'm going to measure going across. Also have number 2, 3, 4, 5, and 6. And as you can see, there's a variety of samples. If you happen to be a club member and you're looking to submit water, this is really what I'm looking for. It's easy to work with. I can put the cap on and off. It's make sure it's nice and clean when you give it to me, and that's the right size. I don't have any worries with that. It's getting stuff like this is obviously we're going to test this water, but it can be hard to pour into the sample. It can take a little bit longer, and this isn't bad, but it's a little small, and so our requirements actually, the form actually asks for about a half a liter, I think is what it is, and this is only 236 milliliters, so it's a little bit less than what we would need. We should be able to get the test done with this, but if we were to have any errors or problems, then it would be cutting it close. Alright, so the first thing we're going to test is the total hardness. And actually, I tend to do both. I tend to test each sample for total hardness and calcium hardness. And what you'll see in each of these kits is the a nice set of instructions, and so it talks you through exactly how to do it. So if you're not a chemistry expert, it's okay. As long as you can count drops and follow directions, you should be able to do it. And these directions are fairly straightforward. One thing we did find pretty early on in this testing is that in this particular one, the resolution's plus or minus 20 parts per million is calcium carbonate. So it was a really kind of rough measurement for total hardness, and really wanted to have a little bit more resolution in what we were looking at. And it's actually pretty easy to just double your sample. So, you know, this is the sample jar that we'll do it in. This is just a measurement so that you put the right amount in. So we just do it twice. And with all the reagents, we just double that as well. And then when we're doing our titration, drop count titrations, which you'll see in a minute, we just, you know, basically each drop is 10 parts instead of 20 parts. All right, so I'm filling the sample up now. As you can see, I've filled this up all the way with water, and now I'm just going to take that and place it in the sample jar. Sorry, I had to look away so that I didn't make a mess. And then I'm going to repeat that again in order to do it. There's still a pipetter, which makes it easy to get the sample out. Now I have in this jar basically 2 of these vials worth of water has now been added into this one sample jar. This is what we're going to use to conduct our test. The first thing we're going to add is the buffer. So for this particular test, we use the buffer solution hardness 1. And if you look at the instructions, it basically says to add 3 drops of the buffer solution hardness 1. Since we doubled our sample, we're going to double that as well. So we're going to add actually 6 drops instead of 3 drops. 1, 2, 3, 4, 5, 6. It's important when you do drop titration, you want to make sure you're holding your pipetter very level and even so that you get a good consistent drop size. Next, as you can see in the instructions, is to add 1 drop of the hardness indicator solution. This one wouldn't matter if I doubled it or not, but I will just for the sake of convenience and the fact that I have way too much of this, do a double of this as well. So we're going to add 2 drops. 1, 2. And again, swirl to mix. Alright, so now we're going to do the titration, and as you can see by the instructions, essentially you add the EDTA titrant drop by drop, counting and swirling as you go, and what we're looking for is for it to change from pink to blue. So here's our titrant. One drop. Now this is normally a lot easier because I don't have a second hand holding a camera, so I can kind of hold it in one hand and swirl without having to put it down. 3. 4. 5. 6. And that's what you're trying not to do, so it's not a good drop. But I'm still counting that as 7, 8, 9. I was thinking about changing now. I'll just try to give it a good swirl as I get up close here. And finally, 9. And you can see, magically, it is now turned from pink to blue. So that was 9 drops, and as per the instructions, you're supposed to take that and multiply it by 20, but because we doubled, we're actually multiplying it by 10. And so we will write down, as soon as I find my pen, the total hardness value of 90 for sample 1. Alright, so now we're going to do our second test. Our second test is for calcium hardness. And for this one, once again, we've put a double-sized sample in. I didn't think you needed to see that part. And this is buffer. In this case, it's the potassium hydroxide 8 normality. So we're going to add 4 drops of this. And again, swirl to mix. And now we're going to actually do a different kind of indicator on this one. This one's a powder indicator. They just call it calcium indicator, so honestly I'm not entirely sure what's in it. But it's in this little pillow pack thing, so I just ripped the top off and put that in there, and then we dispose of that safely. Okay, get a nice good mix of that, and once again we're going to use the same EDTA titrant, same process, 1 drop and 10 parts per million. So put in a drop and count. 1, 2, 3, 6, and once again we've turned it from pink to blue. That was 6 drops, so that's 60 parts per million calcium, and we will write that down for sample number 1. Alright, our next test is going to be for alkalinity. There's actually kind of 2 components to this. We test for phenolphthalein, and then we test for I never can pronounce this, but the bromocresol green methyl red. And generally speaking, the phenolphthalein doesn't really do anything. Alkalinity, by definition, is the amount of strong acid it takes to change the color of the bromocresol green methyl red. And so that's exactly what we're going to do. We use sulfuric acid as our strong acid. And in this case, this particular test, the instructions actually had a high range and a low range. And so by filling the sample jar to the 23 milliliter mark, we're able to use a low range. So first thing we do is put in the phenolphthalein. And if this were to change color, it would indicate the pH of this is greater than, I think it's 8.3. And so far I've never seen that happen on any of the water samples that we've tested. And so once again it does remain colorless, so there's really nothing to do here other than to know that we don't have any pH greater than that level. Now we're going to add the bromocresol green methyl red. And this one obviously does change it to this nice green color. And I'm going to try to get it a good swirl, get all of that stuff mixed in really well. Alright, so just like with the hardness test, we're going to do a drop titration. And give me a minute to get the samples, the solution ready. Alright, so this time we are trying to change this to a nice pink color. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see it's thinking about it, but it's not quite there. 12, 13, 14. 15. I think we're going to have one more drop here. I was wrong. 2 more drops. Alright, this is what I'm looking for here. Nice clear pink color. So that was 17 drops. Unlike with the hardness one, because of this particular measurement, we're going to multiply it by 5. So that would be 85 parts per million ascorbic carbonate for the total alkalinity. Alright, next test is for chloride. And for this one we use a silver nitrate titrate. Be a little careful with disposal of this stuff. And this is another pillow pack. This is a chloride indicator, and it will make it turn nice, bright, and yellow. So for this one, we add drop by drop of silver nitrate, and what we're looking for is to turn it orange, but not rust-like. A little subjective on this one. 1. Well, that's pretty much there. 2, I always like to go one more than I need to, just so that I can see that rust looking color. You can see it coming in there. It looks all kind of red and rusty and nasty. I'm actually going to go with the 2 drops. This is really low chloride water. And in this case, again, we multiply by 5, so we would call this one 10 parts per million of chloride. And this is actually of the chloride atom. Sometimes you'll get tests back that show it as something else, but free chlorine or something along those lines. But in this case, it's this test is as chloride. So the final test that we're going to do here is for sulfate. This one's a little different. This one also takes the longest, but I went ahead and did all the other parts ahead of time. Essentially what we did is we filled this with, there's a line you can't really see on here, but filled this to the correct line with water, and we added a sample which causes a turbidity to it, and as you can see on this one, there's really not a whole lot of turbidity. What we're going to do after we shook it up, I had to sit for 5 minutes, which is why this test takes so long. What we're going to do is we're going to add that now to this graduated cylinder. And then what we have is this very fancy dipstick, basically. It's a dot on the end. And when you put it down in there, in theory, if you have any turbidity, you can look down and you would not be able to see the bottom of it. If I get another sample today that has that, I'll take a video of it. But as you can see, this one, I can still see the dot all the way at the bottom. So this is any amount of sulfate that's in the sample is well below the minimum detection on it. Technically, this thing's got a minimum detection of 50. You can see that's the first mark on here is 50. Really though, I mean, I've seen, I can guesstimate below 50 to some extent. So 50 is the absolute minimum that you could say, oh yeah, this is what it's at. But this one I would say has to be less than 10 or 15, just based on experience of seeing this and seeing external labs results as well. So I'm basically going to write down less than 50, and that's our official result. But I normally tell the person my guess as well on it when we give the results. So there we go. That's our first sample. I'm not going to bore you with the rest of them. But if I do see it when it has a little bit of sulfate, I'll show you what that looks like. Alright, so I wanted to show you what a sample that actually had some sulfate in it would look like. So you can see this one here is a bit more cloudy than the one we were just looking at. This is the sample 3 from our testing today. And so when you look down in this now, you really do not see the dot. And so you kind of raise this up, and there it starts to appear, and disappear again. And so at that point you read off the side what the number is, and assuming I didn't jiggle it, so that was reading about 65. So I'll test that again when I'm not trying to hold the camera and do it at the same time. But you get the idea now of how this turbidity test would work. Okay, so now what we're going to do is record our information in the computer. So this is the form that we use. At the top, we first put in the sample date, so the date that the sample was taken. Followed by that, we're going to put the test date in. That's the date that we performed the test. As typical with our process, it takes a while between the sample date and the test date because it takes a while for me to get around to doing it. Then we have a location information, so this is a descriptive of where the sample was taken, what kind of sample it was, in this case a shallow well, and it was taken in Goochland County. So then we come down to where we actually put our numbers in, and this comes straight off the sheet. So the total hardness that we measured was 90 parts per million. We record that, and then we put the calcium hardness in as 60, and then we do that, it calculates the magnesium for us. Total alkalinity that we measured was 85, and so it calculated the residual alkalinity. The chloride was 10, and the sulfate, I'm putting 10 in, it was very, very, very low. As a result of that, you can see these other numbers were calculated. The bicarbonate number of 104. It also calculated a sulfate to chloride ratio of 1:1, which it called balanced. We can look at some of these formulas. So if you look a little bit closer, the residual alkalinity formula, you'll see that it's actually a function of the total alkalinity, the calcium hardness, and the magnesium hardness, and it essentially subtracts out the appropriate fractions from that. Similarly, we can look at the formula for the bicarbonate. That's based on essentially how the total alkalinity number came from, and the calcium magnesium numbers came from the hardness, just converting from parts per million as calcium carbonate to parts per million. The balanced is based on a lookup table. So if you have extra sulfate versus chloride, you're going to end up with something that's a little bit more bitter, and vice versa. So we also need to save our worksheet. So here we're going to save it first as an Excel format, so we can go back and look at the data and the numbers and make adjustments if we made any errors. So I put the sample date and description and save it into the folder that we have all these stored in. We also are going to save it as a PDF. That's generally how we send the information out to the person who submitted the sample in the first place. So again, I put, in this case, the sample ID. This was sample 34, and the description of what it was along with the date. And that's it. Thank you for watching this video, the James River Homebrewers water testing.